Balance the equation aluminium solid plus hydrochloric acid goes to hydrogen gas plus aluminium chloride. So to start balancing this equation, we need to know where our reactants are and where our products are. So the reactants are always what's on the left-hand side of the equation, so in this green colour, and the products are always what are formed, so we have hydrogen gas and aluminium chloride solution. If we look at the state symbols, we start with aluminium as a solid. We add that to hydrochloric acid, which is aqueous, that's because it's hydrogen chloride dissolved in water, and we form a gas of hydrogen and a solution of aluminium chloride. So to start balancing, we need to know what is unbalanced. So if we look on the reactant side, we can see that our aluminium is 1, and on the product side, it's also 1. So at the moment, our aluminiums are balanced. If we look at our hydrogens, on the reactant side, there is 1, and on the product side, there are 2, so they are not balanced. If we look at our chlorine, there's 1 on the reactant side, and there are 3 on the product side, so again, they are not balanced. So now that we know what's not balanced and what is balanced, we can start doubling up or tripling up what we have in the equation to try and balance it. So if we start with chlorine, we can see on the product side there are 3 of them. That means to balance it on the reactant side, we would need 3 HCl's. But before we do that, what we can see happens then is that our hydrogen becomes 3. And on our product side, hydrogen is 2. So in order to make this hydrogen 3, like what would happen to our reactant side if we put a 3 here, that means this would have to be multiplied by the fraction 1.5, or 3 over 2. And when we balance equations, we don't like to have fractions. So in order to stop that happening, that means we need to make everything even. So at the moment, our chlorines are odd. We have Cl3. So to make that even, we can double it. And then we see that we have 6 chlorines. So to balance it on the reactant side, we would need a 6 here. And that also makes our hydrogens nice and even. So now we can put a 3 here to make hydrogen 6 on the product side. And then finally, if we look at our aluminiums, there's 1 on the reactant side, but there are 2 on the product side. So we need a 2 on the reactant side. So now if we have a look, our aluminiums are both 2. Our hydrogens are 6 on the reactant side and 6 on the product side. And our chlorines are 6 on the reactant side and 6 on the product side. So that is a fully balanced equation.